So ladies and gentlemen, my name is Sharon Whiteman, and I partner with Dinah Hunter and Gary Knapp each and every Saturday to bring excellent education to the Australasian community who are, today we're talking about being wellness warriors. We're spreading the news and the mission of not only our Glycan technology, but also our M5M program, which serves disadvantaged children and malnourished children around the world. Today, we're very privileged to have Dr. Steve Nugent. Don't tell anybody else, but I think he's our favorite speaker. Dr. Steve Nugent is Manitech's Chief Science Officer and Chairman of the Global Scientific Advisory Board. He has more than 40 years of experience in the area of integrative medicine. He has tested more than 6,000 dietary supplements, formulated more than 100. He is internationally recognized as an expert in his field, and he's been teaching doctors for more than 30 years. He is Manitech's most requested speaker worldwide. He has earned multiple degrees, graduating with top honors at both the undergraduate and graduate levels. His areas of studies include integrative medicine, health and wellness psychology, organizational psychology, neuropsychology, biological anthropology, nutrition science, and business administration. Dr. Nugent is served as president of the International Association of Complementary Medicine and is president emeritus of the American Naturopathic Medical Association. He is a professional member of the American College of Nutrition, and he is also awarded the Servant's Heart Award by Manitech Associates in 2007. There's never been a more important time in history to learn how to empower your innate immune system and cellular function. And Dr. Nugent, as an educator, carries the well-being of each and every one of us on his heart and on his sleeve. So Dr. Nugent, we're privileged and honored to have you.
Well, thank you, Sharon. Thank you for that introduction. Good morning to all my friends in Australasia. I hope it's a beautiful Saturday morning for you. Well, we're going to do something a little bit different this week, or this month, I should say, since I do these only once a month. We're going to do a generic presentation, which is primarily the one I use for countries that do not permit us to talk about products or companies. Now, you might say, why would you want to do that? Well, I'm going back a long time. From Manitech's beginning, which is now getting close to 30 years, if you can believe that. From the beginning, from the very first lecture I ever did for Manitech Associates, and that was before I was an employee of the company. I was in practice at the time. And I had the same questions, which have continued for nearly 30 years now, and that is, well, I've never heard of glyconutrients or glycans, and I haven't seen it advertised on TV, and my doctor doesn't seem to know about it. And is there any science behind it? Well, of course, most of you on this call are regulars. Most of you on this call are associates, and you know that there's just a ton of science. But you may not know how much science there really is in glycan research. So when I have to go to a country, and I just returned from Thailand, which was a very, very successful trip for us. We are going to do very well in Thailand. In Thailand, they do not permit you to do presentations that include identification of products or companies. So, and the same thing when I go to the People's Republic of China, it's not permitted. So I have to do presentations where I can't even identify myself as being from Manitech. I just have to be a researcher in air quotes, okay? So that's what this presentation is about. But why is it useful for you? Well, I'm going to give you information about the history and the science of glycans that literally goes back thousands of years. And this, I hope, will help all of you to feel even more confident about how amazing glycans are for your health. Just in case some people aren't up to speed on the word glycan, okay? Glyconutrients is a commercial term that was invented by Manitech, actually, in 1996. The scientific term for what we're going to be talking about is glycans. So glycans is what I'm going to be referring to. When you talk to a doctor or a scientist about glyconutrients, usually they say, what? If they're familiar at all with glycans and you say glycans, oh yeah, I've heard something about that. What you may not know is that the history goes back thousands of years, but we are now, boy, are we at a great place. And we are at such a great place because the Nobel Prize in Chemistry was awarded for glycan technology in 2022. So there's a lot to talk about here, and you'll understand why I'm going to go through this. Now, for those of you who say, well, I don't understand if you say glycan, but you don't specifically mention a product, you'll get it. You'll be able to put it together. I think you'll be able to handle it. Okay. So I have some slides, and I'm going to share screen here. And hopefully everybody will be able to see these. And if you can't see them, let me know, but I'm going forward. Okay.
And we
All
can't
right,
see any
so
slides, Dr. Nugent?
you can't see any slides.
No.
Well, hang on a minute. I don't know what's wrong there. Do you see slides now?
Yes, we do.
All right, great. Super duper. All right, let me just get to the second slide. Don't need an introduction slide, I don't think. Okay, so plant saccharides. There's different ways to identify glycans. The scientific term, again, is glycan. You've often heard people talk about plant saccharides, and the word saccharide simply means sugars. But when you say sugar, you always get some people who have a totally different idea of what you're talking about, because they're thinking about those dangerous, unhealthy sugars that taste wonderful and we love the taste, and we use those sugars to sweeten our drinks and our food, and that's not what I'm talking about. So when we say plant saccharides, and it does include those sugars, the bad ones, but the overwhelming majority of sugars are plant sugars that don't taste good at all. They're not sweet. In fact, a lot of them just taste like sawdust. I mean, they just don't taste good at all. And they don't raise your blood sugar, and that's important to note. Because when you say sugar, the first thing people think is, oh my gosh, it'll raise my blood sugar. It'll be bad for my health in different areas. It'll cause me to gain weight. No, it's none of that, because it's not that kind of sugar. So the sugars we don't use and will not be talking about in this particular training are those sugars called disaccharides, okay? And those are the ones we use to sweeten our foods. And we're not going to talk about those because they're of no value scientifically, okay? They're not good for your health. All right, so of the plant saccharides that are known, there's just about 215, I think, that have been last cataloged, and who knows, there could be more, but that's what we know of right now. And the table sugars, as we mentioned, just to make sure that no one had any doubt in their mind that these good sugars are not unhealthy, even though they're called sugars. And that's sort of like saying acids, right? All of you know that there are acids that are so caustic that if you put one drop on the bonnet of your car, it would eat right through the steel. You know that. But there are also amino acids, and those acids are essential to your life. So it's a big umbrella. Same thing with saccharides. It's a big umbrella. A couple of them are not good, and the rest of them are very good, even completely necessary for every aspect of your health. And we did a double-blind placebo-controlled study, human study, where we tested people's blood sugar just to be sure, and we found that these healthful saccharides or glycans do not raise blood sugar. So put that one to bed right away. Now, the history of glycans literally goes back thousands of years, literally back to the time of Alexander the Great, when his physicians in his army, as he was attempting to conquer the world as he understood it, he had aloe plants in wagons that were part of his supply train. And the reason for this is because everyone knew back then in 340 BC, everyone knew that if you got a cut or a wound and you put some fresh aloe gel on it, you would heal much faster and much better. And that's why they had these special wagons of aloe plants with men assigned to do nothing except take care of those aloe plants. So that tells us a lot going way, way back. Now, because we have so many people in Australasia who are of East Asian descent, they are all familiar with something called bird's nest soup, but they may not realize, besides the fact that it's very expensive, but they may not realize that what makes bird's nest soup work are glycans. Yep, that's been confirmed scientifically. Well, as we started to go forward and science is beginning, just sort of taking its baby steps in the scientific method, 1857, we have our first scientific paper, such as it was, on glycans. And this was to investigate glycans in your mouth. And by the way, I have an entire hour presentation that I do just on glycans and oral health. We won't do that one this morning, but so there's a lot about glycans and oral health as well that you've never heard me talk about and you probably were not aware of. Well, then we go forward and the structure of glycans begins to be examined, because we know in science that structure equals function. So it's important to understand the structure of whatever it is you're studying. Well, they found in 1906, they found a glycoprotein. Now that means a glycan, which has bonded itself to a protein. Now it is a glycoprotein. Now, many of you have heard about cellular communication. Cellular communication occurs when certain receptor sites on your cells have a glycoprotein that has bonded to it so it can send signals. So we'll come back to that as we move forward. 1922 is a really important year in the science of glycans, because it was that year that heparin was discovered. Now, some of you may know of heparin as a pharmaceutical drug, and it is today. In 1922, it was discovered to be a glucosamine glycan. And they found that this particular glycan was able to make your blood stop from clotting. Now, this is very important if you want to save lives, and that's why it is a drug today that has, in fact, saved millions of lives by being an anti-clotting drug. And it all started with the discovery of heparin as a glucosamine glycan. There's some real science there. Now, just to be clear for everybody, because somebody's going to have the question now, oh my gosh, does that mean that all plant saccharides will thin my blood? No, it means one plant saccharide will thin your blood. One, okay. Not the ones that are used for cellular communication. So not to worry. I'm using a science site called PubMed, and that's, it's medical science that's available to the public for free. And it's a site that's in the United States. It has millions and millions. Last time I checked, some 13 million scientific studies. So I'm going to use that as our benchmark. So in 1950, you had your first paper written on glycoproteins. And a lot has happened since 1950. In 1953, this was a really important year because this year, 1953, everybody was concerned about atomic war. And of course, the memories, the terrible memories of the survivors of Hiroshima and Nagasaki, they were trying to figure out, how do we treat radiation burns if they occur? So what they did was Lushbaugh and Hale, these two scientists, took some laboratory rabbits. They deliberately irradiated these rabbits to simulate radiation burns from an atomic blast. And then they treated some rabbits with fresh aloe vera gel and others they did not treat. Well, the untreated ones, of course, died. And the treated ones healed. And this told everybody there's something in that aloe. We don't know what it is, but there's something in that that can even help you with radiation burns. Wow, we need to explore that more. So about 200 papers are written over the 10-year period, and that's pretty good as science advances at that time. And in 1970, they discovered something called the glycocalyx. What is that? In the capillaries of your body, you have these tiny vessels. And so when blood passes through these tiny vessels, there is, how do I describe this? It would be sort of like there were a lot of hairs. It kind of looks, under a microscope, it looks like a bunch of hairs on the inside of the capillary. And these hairs regulate what passes through the capillary. How does it do that exactly? Scientists are still trying to figure that out, but that's what regulates what will pass through the capillary and what will not pass through the capillary. Those little hairs are made of glycans. Very important discovery. And in 1971, some scientists were thinking, you know, I wonder just how far the immune properties of fucose, that's a glycan found in several different plants, wonder how far that could go. So what they did is they got some laboratory rats that were healthy. They deliberately implanted tumors into the rats that are always 100% fatal to rats. And then they treated them with a glycan called fucose. And guess what? The rats survived. All of them survived. Wow. Well, once again, the scientists doing the study didn't know why or how. They just knew it happened, and more study was needed. As you see written at the end of virtually every scientific paper, more study is needed. Then in 1974, the American FDA finally approves heparin sodium as a prescription drug to start saving lives. That has prevented so many strokes. That has saved so many lives in hospitals with surgeries and so on. It's just really, really a big, big discovery back in 1974. Once the FDA had done that, the rest of the world then began to do it as well. So by the beginning of the 1970s, we now had 1,200 papers published on glycoproteins. And by 1980, it had gotten to more than 4,000 papers. Very important. The 1980s were very important for us. The man who turned out to be the first chief of science for our company, that man was working for a pharmaceutical company at the time, and they were looking for the immune drug, the panacea of immune drugs. And they asked him to take a look at aloe vera and try and figure out what was inside of the aloe vera gel that was doing all these remarkable healing things. What was it? Well, of course, in the 1980s, science at that time was focused on proteins. Everyone was sure that it had to be a protein. And in fact, this scientist was looking for a protein, and he was surprised to find out it was not a protein, it was a carbohydrate. It was a carbohydrate called mannose that's found in the aloe vera gel. Now, when he first pulled this out of the gel, as soon as it was exposed to oxygen, it began to degrade almost immediately. And that's why fresh aloe gel works, but aloe gel that's not fresh doesn't work because it degrades as soon as it's exposed to oxygen. So he had to find a way to stabilize it, which he did. And if it wasn't for him in 1983, nobody would be using any effective aloe product today at all, anywhere. And that's really important stuff. Well, they tried to make it into a pharmaceutical drug, and I love this story. It's a true story, and it's a wonderful one. In order to prove, or I should say, in order to get approved for a drug license in the United States, which is where this drug company was, you have to be able to show how dangerous your drug is. I know that sounds kind of funny, doesn't it? Well, the purpose is you want to show at what point does the drug go from helpful to harmful. That's the idea. And they call it LD50 is the official name for it. So at what point can you kill at least 50% of your laboratory animals? Well, this scientist worked at it, and by the time he got up to 100% pure mannose from aloe, he couldn't kill even one lab animal. In fact, they all got healthier. All their immune markers, their aging markers, their body fur got thicker and softer, and they began to multiply much faster than they would normally do. So it was clear that it couldn't be approved as a drug. The pharmaceutical company was so unhappy. They thought, we've made this discovery, and so what, who cares? Well, then they thought, let's turn this into a wound gel, thinking back to Alexander the Great and Lushbaugh and Hale's experiment. So they made something called kerosene hydrogel, and it became the most important and most widely used wound gel for burn centers and trauma centers all over the United States. And that stayed for a very long time. Now, that particular company, which was called Carrington Labs, that pharmaceutical company went out of business, probably due more to mismanagement than their product. But that's a different story, and I don't have all the details, so I won't carry on with that. Now, in 1985, they found how glycans link to the receptor sites on your cells. And these are called N-linked glycans. You have two types of glycans, N-linked, nitrogen-linked, or O-linked, oxygen-linked. And they found that it was the nitrogen-linked ones that were doing the healing. And that was very, very important. By 1990, we now have 12,000 papers on PubMed. Now we're getting somewhere. And in the Journal of Glycobiology, they really studied the structure of the chains of the sugars. That was very important work that year. And in 1990, also, Biotechnology magazine, they said, almost without exception, whenever two or more living cells interact in a specific way, cell surface carbohydrates will be involved. And we find that that message gets even stronger as we move forward in the science. In 91, they tried to make an injectable. In fact, they did succeed making an injectable from aloe vera gel, from this mannose that was taken from aloe vera gel, which by the original scientist was called ace mannan. That's what he referred to it as. Now, it is important to note that an injectable is made in very specific ways, and you cannot take a powder form of glycan and inject it or put it into an intravenous drip. Don't even ask me, you can't do it, all right? What I'm talking about here is the fact that through the means necessary to make it into an injectable, they used it for cats and dogs and found tremendous veterinary applications for the cats and dogs, for their immune system, and so on. And in 1992, and this is a great story and an absolutely true story again. Chickens, of course, are a very big part of the food chain in almost every country in the world. And chickens, especially huge chicken farms, birds, they seem to attract viruses like magnets. In fact, most of our most serious viruses that have been transmitted to humans have originated from birds. Well, this year, literally millions of chickens are dying from a virus. So they take this injectable that they made for cats and dogs, they modify it slightly, and now they begin to inject it into the chickens. And the result was they took care of that virus problem, and more than 1 billion chickens in the United States were saved that year. Now, once again, a powdered form of glycans cannot be used in an IV or an injectable. It's a very specialized process to do that. And we also found that in 1994, there seemed to be a list of glycans that were important for immunomodulation. We'll talk more about those in a moment. Now we're looking at cell surface carbohydrates, or glycans, and immune recognition. This leads us to thoughts about cellular communication. And in 1996, one of my dear friends, Dr. Robert Murray, he publishes in Harper's Biochemistry that there are 8 glycoproteins that are necessary for cellular communication. Without these 8, your cells can't talk to each other. If your cells can't talk to each other, you don't have function. If you don't have function, well, you're not well. So that was key. And also in 1996, the same scientist who discovered the functional component of the aloe vera plant, he was working on a concept of putting these glycans together in a cellular communication complex. And this was a powdered glyconutrient or glycan complex. And he created this in 1996. And of course, the first patents then were applied for in 1996 as well. In 1998, one of the most highbrow of all scientific publications, it's called Acta Anatomica. They devoted an entire volume, and we're talking a volume here. This is not a magazine or a journal. This is practically a book, and it's all about glycans and glycobiology, and it is so complicated that even some glycobiologists I know have kind of a struggle reading through it. If you can read through it easily, then I need to talk to you and find out what you're doing. In 1998, then, we have a study done on congenital defects of glycosylation. Why was this done, you might ask? Well, in medical schools, as soon as glycans were discovered and cell surface carbohydrates were linked to cellular communication, they began to teach medical doctors something called the glucose-only theory. And the glucose-only theory says, basically, as long as you have glucose in your blood, that glucose will always convert in everyone in all circumstances. And so you don't need to supplement, obviously, as long as you have glucose. Well, guess what? It's not true. The glucose-only theory is still being taught in medical schools all over planet Earth right to this day, even though the first studies on congenital defects of glycosylation were published in 1998. And that year there were 13. Today, hold on to your seat, today there's 140. So these are 140 circumstances where individuals will become unhealthy. They will not be able to convert glucose into the other 7 glycans for cellular communication. So if your doctor says to you, oh, well, as long as you have glycan, as long as you have glucose, that's all you need. Well, that doctor is wrong. And that doctor needs to be caught up on CDGs, okay? 140 CDGs, now no. So clearly there's a lot of times where people can't get what they need from conversion in their blood. Technically, in the science community, we still use the word necessary and not essential. I have seen marketing material, lots of marketing material, that uses the word essential, and that is incorrect, because if you can convert it, it's necessary. If you can't convert it, it's essential. Now, in 140 cases that we know of, you're not going to be able to convert it. So in those cases, it's essential. But for the majority of the population, it would be necessary. And for most of you, you don't care about that distinction. And in fact, in some languages, there is no distinction between those two words, which I found out very recently. I apologize for that interruption as we're going through this. Forgot to turn off my phone. Sorry about that. It's always someone that needs to connect. Well, then in 1998, we had the first patent issue that was in South Africa. Moving up to the year 2000, we now see that we're starting some whole new ideas about glycans. What we know by the year 2000 is that glycans seem to be necessary for most functions. Maybe we'll find out for all functions. We don't know yet in the year 2000. And one group of scientists, I should say, in Japan, they start the Human Glycome Project. You know about the Genome Project, right? That's a study of all the genes. And the microbiome is a study of all of the microbiota or microorganisms that are necessary for your health in the gut and also on your skin. But the Human Glycome Project was to study what do all the glycans in the human body actually do. That's a big project. That's going to go on for a long time, but I want you to know it's ongoing and it's important. So when someone says to you, oh, I don't think there's any science out there, folks, there is so much science. You're probably already overwhelmed, and I'm not done yet. There's lots of science to talk about. So when you see me get excited about glycans, hopefully you'll understand even more why I'm excited, because I know about so many of these studies that I've read, and it's just exciting stuff for us. Well, the impact of glycobiology is becoming so significant, even by 2001, that the world famous Scripps Institute issues $34 million in research grants for glycans to find out what glycans are doing. Remember, we've seen the results of what glycans do, but scientists can't explain quite why yet in 2001. So that's important stuff. And of course, they're now mentioned in the famous physician's desk reference for non-prescription drugs and dietary supplements in 2001. And the National Institutes of Health in the United States, they also issue another $34 million in research grants. And this total of nearly $70 million in research grants allows scientists to do all kinds of important studies and move forward even faster. So that money is so important for the research. In 2002, we now see a publication that says the glyconutrient complex, this is a powdered glyconutrient complex made of glycans from several different plant sources. It actually has a positive effect on brain waves. Then scientists thought, maybe this could help improve brain function and memory and mood and so on. So studies had to be done now in that area. A very good friend of mine, Dr. Stephen Boyd, presented a number of papers, but this was an important one at Oxford at the Jenner Conference. And if you're in the science community, this is a really big deal, this conference. So it was important that one of their presentations there was about the glycan complex. Now, by 2004, we got about 18,000 papers written. This is really important stuff. And by 2005, an Australian researcher named Dr. Talitha Best, she does a very important study about memory and the glyconutrient or glycan complex. She gives 4 grams of this powdered complex to test subjects that she has administered memory testing to in the morning. Later that day, she tests them again with standard memory testing and finds that they had improvement in memory function in a single day with only 4 grams of this glycan complex. Now, folks, that is super impressive. No scientist can walk away from that and not be astounded by those results. Now, Dr. Best did several studies on the glycan complex, but that was a very important one. And by the way, and I know I have a little bit of a bias here, which I will admit to. As far as I'm concerned, if somebody was going to give a major award for brilliance in science to an Australian scientist, it should go to Dr. Talitha Best. That's the way I feel. Well, anyway. In 2006, my good friend, Dr. Robert Murray, who had identified the 8 glycans for cellular communication, he presents a poster on glycans at the Scripps Center presentation for integrative medicine, their 3rd annual meeting on natural supplements. And that was a pretty big deal at that conference, and it opened a lot of eyes for a lot of the scientists there. By the way, during that same year, there was a study done on whether or not glycans could in some way affect probiotics in the gut. Now, the idea was, we know that both sugars and fibers can be prebiotic, that is to say, food for probiotic bacteria. So in the study that was done that year, what they were trying to find out is, could this glycan complex have a positive effect on probiotics? And the answer was absolutely yes. The glycan complex is a prebiotic, and it does feed the probiotic. And what's very, very interesting, I love nature. I just love it. In order for a glycan to break down into the components that are required for it to be used for cellular communication, it has to interact with probiotics in your intestinal tract. And while it interacts with the probiotics, it's also feeding the probiotics at the same time. So you have this marvelous sort of symbiotic relationship between increasing the health of the probiotic while the probiotic breaks down the glycan into subcomponents so it can be used in your bloodstream. So what happens is you start with 10, not 8, but 10 glycans in a powder. Those 10 get into your intestines, they interact with the probiotics, they break down into their subcomponents, and they pass through your intestinal wall into your bloodstream as the 8 that are necessary for cellular communication. That's the way it works. And I think it's marvelous the way it works. Now, we also had a study done in 2009. In fact, 2008, 2009, there was a lot of important work done. But in 2009, there was a paper on visual discrimination and working memory. I remember we had already seen things with brain function that seemed to be important. We knew that brain wave activity can be affected by glycans. And now there's lots of money out there for study. So one scientist says, well, maybe we should look at motor skills. And why is that important? Well, it's important for a lot of reasons. There are people with impaired motor skills, obviously. But let's say that you're an athlete, as an example. And in fact, I had this question. I was presenting at a conference, doing this generically, of course. And afterwards, one of the doctors that I knew outside of the conference, he said to me, do you think that glycans could improve my golf game? And I said, well, we know that glycans do. The glycan complex does improve visual discrimination, which is obviously would be necessary for that game, and also working memory. So yeah, it should help a golf game, but in your case, probably not. I just had to take a little jab at him then, just kidding with him, just between friends. So this is important now. We're learning more about this in the early 2000s, and more study is continuing. And now we're looking at another study in 2010 on prebiotics and probiotics. And again, it's confirmed. The glycan complex made of these 10 glycans, this glycan complex works as a prebiotic and improves probiotic health and the colonies there. Dr. Talitha Best in 2010 comes back and does another study. By the way, she's a neuropsychologist, just in case some of you don't know. And this was on cognition. So how does your brain work? Can you improve your basic brain function? And of course, again, on memory. Very good paper. And then again in 2010, yet another paper is done on immunomodulation and glycans or polysaccharides. Now, in case you don't know what immunomodulation is, let me explain that to you. Some people think about immune stimulation. So that is going above normal. And some people think about immune suppression, and that is to bring a overactive immune system down to normal. But the ideal condition for human health, ideally what the human body is programmed to do, what it strives to do, is what's known as immunomodulation. So that is trying to keep you at normal balance. Too high, bring it down to normal. Too low, bring it up to normal. That's immunomodulation. That's ideal. And that's what these glycans apparently do, according to scientific study. Also by 2010, we're up to almost 23,000 papers now. That's really moving forward, really moving forward. And we now learn more about glycosylation. In fact, the critics of glycan supplements, so they were saying, well, if you take it orally, where's your proof that it's going to end up on your cells? Well, the proof came in 2011. There was the proof. And we found that glycosylation, that is the bonding of the glycan to the cell surface receptor sites, that's called glycosylation, that was accomplished using a glyconutrient or glycan complex taken orally, that powder taken orally. It did in fact glycosylate the cells, and then you go forward with function after that. Then of course there were more studies on brain function and behavior. I won't go too much through all of those. In 2020, there was another study done at the University of Memphis in the United States on immunomodulation and the reduction of adversity to the cells. That's pretty important stuff. Then in 2022, the Nobel Prize in Chemistry was awarded to the three scientists you see on the screen. Carolyn Bertossi is a chemist turned glycobiologist. She's just fascinated by glycans, and we're glad she is. And the purpose of the study, and you can try and read about and understand it, and you have at it. I don't have time this morning to go through all the details, but here's the basics. Knowing how glycans, or I shouldn't say knowing, observing what we know about glycans so far, she reasoned that if you took one type of glycan and attached it to a chemotherapy drug, and you took another corresponding glycan and attached it to the target cell where you wanted the chemo to go, that they would attract each other, and that you would not have any collateral damage to any cells from the chemotherapy drug. You would only damage the target cell. Now, her study, the theory is early. The study is animal study. We don't have human studies yet. I believe that she will succeed. It may be 5 years or more before she is successful. I don't know. I have no psychic ability, so I can't predict that. When she succeeds, what's going to happen is that you will have one of the greatest steps forward in that area of healthcare in the history of that area of healthcare. That is astounding stuff. And it's all about glycans. Now, I want to stress for everybody, before you jump on the bandwagon here, not all glycans are the same. Different glycans have different functions. Remember, heparin has one kind of a function. Different glycans have different functions. So we are not talking about a powdered glycan complex here. These are glycans, but they're two different glycans from the ones that we have talked about thus far. I simply wanted you to know that the science of glycans is accelerating, and it's becoming so exciting. It's really, truly the most exciting area of natural health care that I know of on planet Earth at this time. All right, so in summary, from the history, and I've got some particulars for you about aloe and allopectin that I'm going to cover for you in the next few minutes. But I want to summarize where we're at this point. Glycans are necessary for literally all functions of the human body. All. Doesn't matter what the function is. So if someone says to me, I have concus of the bronchus, should I take glycans? I say yes. And if someone says, I have non-concus of the bronchus, should I take glycans? And I say yes. In fact, I say, if you're breathing, take glycans. So you don't have to ask me that question. So immune modulation, I've already explained to you what that means. The brain function, memory, mood, motor function, visual discrimination, the gut-brain connection, study ongoing in that area. Glycans are crucial in that important area. Your gut microbiome, the health of your gastrointestinal tract, your oral microbiome, all glycans are necessary in all those areas. All right, some of you have seen this picture before, and this, by the way, is an oversimplified picture. greatly oversimplified. If you actually look at a microscopic view of the cell surface, that number of that number of receptor sites that you're seeing right now is nothing compared to the way it actually looks. The reason this drawing was made was simply to show you that the glycans attach to their receptor sites and enable function for immune system, hormone function, signaling, detoxification, the list goes on, all right? But if you're really looking at the surface of the cell, imagine for a moment that you're in a helicopter flying over the Amazon rainforest. Now, as you look down at the Amazon rainforest, you can't see the ground. All you can see is this massive canopy, the tops of all the trees. That's all you can see. Well, when you look down on a cell, all you can see is this massive canopy of glycans. Glycans are that important. Your cells are just covered with them. Really, really important. And again, there are more than 200 known at this time. Ace-mannan is the one from aloe, but there are others from other plants that are very necessary. One of my favorites is called arabinogalactan, and I think it is the second most important of all the glycans, arabinogalactan. Now that comes from a tree, the larch tree, which grows primarily in North America. And arabinogalactan has been tested in human double-blind placebo-controlled study. And what they did was they selected groups who were receiving either a flu vaccine or a pneumonia vaccine. And some of the group got arabinogalactan, some of the groups did not. And what they wanted to see is, how do these people respond to their vaccines? Does the arabinogalactan help to modulate the immune system in a way that would improve their response to vaccines? And the answer was yes, arabinogalactan, very important. And that provides glycans that are typically associated with a glycan complex. I also want you to understand that every product that contains aloe now calls itself ace-mannan. All of them do. I don't want to argue with people about, this definition, that definition. The original definition was made by the original scientist that made the discovery. He said that ace-mannan has a weight of 1 to 2 million daltons. Dalton is a measurement of molecular weight. If you're using that as part of your definition and you compare true ace-mannan to mannose from aloe that's standard aloe, you're going to find that the Dalton weight is different. All right, if you don't want to talk about the weight, let's do it a different way. Remember, I said structure equals function. Let's look at the structure. Ace-mannan structure, you'll see there in the orange block. Standard aloe structure you see in the block before, the block after it, in a more of a bluish color. You can see the structure is different. You don't have to remember the structure. You don't have to understand the structure. You can see that all aloe, that all mannose from aloe is not the same. You can see that by the structure. And that's what I wanted you to see. Remember, structure equals function. So if the structure is different, the function will also be different. Understand that. So all these companies that say we are all the same, all aloe is the same. Well, all aloe is not the same. In fact, to make what is referred to as true ace-mannan, so ace-mannan that has the structure that I showed you a moment ago, you have to extract from 660 kilograms of aloe leaf to get 1 kilo of ace-mannan. Now, most companies that sell any kind of an aloe gel product, they will machine process in almost every case, and they will have in their product, they'll have something called aloe latex very frequently, not always, but very frequently, because of the way they process, and that they use the whole gel. Well, obviously that's a lot less expensive. Now, by using the whole gel, they'll still have the important mannose in it, but the concentration of that mannose will be far less. Whereas in a true ACE mannan, it's all concentrated mannose, along with something called pectin, which I'll talk about in just a moment. So for cellular communication, ACE mannan for sure. For immune response, immunomodulation, cellular metabolism, digestion, we know that it can help you to absorb vitamin C and E. That's been tested. That's certainly a benefit, no question. Now let's talk about pectin. What you're looking at now is the microscopic view of allogel. And what you see under a microscope is the allogel isn't just liquid goo. There's some kind of structure in here as well. Well, that structure that you're looking at is made of pectin, and the pectin helps you with detox. This is important. In fact, one of the most important natural detox agents that you can find is going to be pectin, and the heavier the pectin is, according to study, the more effective it is for detoxification. Now we know that the pectin, the allopectin that you just looked at in the picture from ACE mannan, has a weight, a molecular weight of more than 1 million Daltons. In fact, currently more than 2 million Daltons. And the heavier it is, the better it helps to detoxify chemical toxins from your body. So that's important to know. We know that according to study thus far, it's been studied with what are called +2 and +3 metals. Now, these are harmful heavy metals that human beings are exposed to all the time. And we know that these, the chemical in the pectin, that helps to sort of attract like a magnet, if you will, because they're opposite charges, opposite poles, okay? And they attract, and that helps to carry it out of your body. We also know that the pectin works as a prebiotic fiber, and that helps to enhance gut health. 2 different probiotics were studied with this, as you see on the slide right now, and with very positive results. So the heaviest allopectin currently made is grown in Costa Rica, and there's allopectin from all over the world, obviously, but that's the one that's currently the heaviest. And we know that this is very important for detox. So cellular communication, cellular metabolism, immune modulation. And what I have found throughout my career is that there are more people that come to me with help for their immune system than anything else. But understand that if you have proper cellular communication, that's what you need for virtually every kind of function in the body, not just immune function. So also brain function and memory support, digestive support, all of those things. So after thousands of years, we are now up to more than 400,000 published papers. So anyone who says to you, oh, I've never heard of that stuff, it wasn't advertised on TV. Well, not every scientific discovery is advertised on TV. In fact, how many people watching this right now knew about the 2022 Nobel Prize in Chemistry? I would venture to say most of you didn't know about it. So just because it's not on TV doesn't mean it's not important. Science is important. And science is moving forward at tremendous speed. We are finding so many new discoveries about the glycan complex and glycans in general. It's just super, super important stuff. I hope that this method of teaching this morning has been very enlightening to you, and I hope that it has further increased your confidence and increased your resolve to help as many people as you can with your knowledge of glycans and glycan technology. So I'm going to go back to Sharon right now. We're getting pretty close to the end of the hour.
It's so awesome, Dr. Nugent. That's such great news. Well, every slide is improving on good news and then better news and then great news. There is
Yep.
one question, I don't know if you can answer or not. And could a synthetic glycoprotein communicate with a natural glycoprotein, given that the synthetics usually have a different molecular shape?
Well, it's all about structure and function. That's the best answer I can give you because the question is general. So far, there have been no synthetic glycoproteins that have been affected for immune function. There are other functions that they've been able to work out with a synthetic, but it's all about structure. It's just kind of like a Lego set. If they have Legos in Australasia, where just all the parts fit together, right? So that's the best answer I can give you.
Awesome. So, ladies and gentlemen, if you're watching this live or down the track, remember this isn't usually the first step of information or education to share with somebody that you care about. This is probably very specialized and it would be overwhelming as a first step for most people, but this should empower each and every one of you to be the best we can be in our community. So Dr. Nugent, God bless you. Thank you very much. I'll be chasing you in another couple months.
All right.
We appreciate you.
All right.
All right.
Bye-bye.
Bye, everybody. See you next week.